Good morning. Got some stories here for you. A couple of them anyway. Thought you might be interested in. These are some stories I got from some buddies of mine that I picked up online. And I did this PowerPoint presentation for my students a few years back, but it's a pretty good one, so I'm going to go for it and give you guys a Monday and launch you off to have a great day. This is a Mazda MPV 3-liter V6. Had a flashing malfunction indicator light, misfiring under load. Comes out with a P0303 174 422. So we recorded the codes, or the guy did, and freeze frame data. It's always a good idea to record your codes and your freeze frame data. And it, amazingly, and I've seen this before too, whenever you look again, it turns into a P0302. You cleared it twice, got the same results. Both banks, and you know why it was showing a 303 is wonky. But it's always a good idea to clear that, let it reset it, so you can make sure you don't go to the wrong cylinder, because that is a problem sometimes. So anyway, got the same result. Both banks were at 15% long fuel trim, added fuel. The coil and boot looked fine. The misfire stayed on number 2 when we swapped the coil and the boot. All right, so now checking primary ignition waves, this is how you do it. If it's an oil-filled coil, you're going to do it to the negative side, from ground to the negative side of the coil. That's how you're going to get your coil, pattern, the primary pattern. Now the secondary pattern is what we used to use, but the primary pattern is going to give you the same information, it's just lower voltage. So you got to recognize that too. You also put a current clamp around this so that you can actually get a good idea of what's going up there. If you current clamp incidentally the injector, you'll actually be able to see when the pintle opens, which is a good thing to do, because you can tell if it's opening or not by just looking at the little bump on the current ramp on the injector. Okay, so this is a normal primary pattern, single primary pattern. Once again, you can see this looks an awful lot like a secondary pattern, but the voltage is not nearly as high. That initial firing line is only about 400 volts instead of 15 to 20,000, but you're still drawing the same picture, you see. All right, and so there's your burn line. There's your upkick that tells you all the fuel has been consumed. And then this is leftover energy down here, these little squiggle. If you don't have that squiggle, if it's just got a little dip right there, then you have got a weak spark. You can illustrate that if you've got one that's got a distributor on it by hooking your scope up to get this pattern, and then touch a low impedance test light, hook it to ground and touch it to the negative terminal on the coil, the trigger terminal, and you'll see this change, and it will show you what a weak coil looks like, because some of the energy is being stolen by that quarter of an amp light bulb that's in that light. Now what is going on here, whenever you've got the initial jump across the line, takes a lot, it takes a whole lot to jump that, but once it jumps, it's burning the fuel. And it's got lower resistance in there while the fuel is burning, because the fuel molecules are conducting. And so as they're used up, and this upkick is not as strong as on some patterns I'll show you later, that upkick means it has used up the fuel, and then the spark burns out, and then this wiggle is leftover energy down here. So get that. All right, now this was a normal pattern compared to what we had. And this is the normal waveform on the Mazda when it wasn't skipping, right? You had to put it under load to get it to skip. There's your coil current ramp, and this is your firing line, which, how high that goes in this case isn't really all that important. And so this is whenever that's your burn time. Now the length of this is important, as is the height of it, as is the way it looks. And so that's, that's really something you need to pay attention to. Alright, so this is what it looked like when it was skipping. Look at that upsloping spark line during the burn time. That right there, when it was misfiring, that tells you right there that there wasn't enough fuel in there. The first time I ever ran into this was one of the first times I ever used a scope was in 1983 at the Volkswagen place. I had a Volkswagen Rabbit that was sputtering and cutting up whenever you would give it the gas. and we had a sun scope over there that belonged to the dealership, and so I rolled it over there and hooked it up. Not difficult to do, you know. And I noticed whenever I give it the gas, you know, just sitting there snapping the accelerator, it would sputter and pop and cut up. This burn line right here would be really crazy, and it would have a bunch of stuff going up and down right here that was just about as tall as that. And the problem with that rabbit was a clogged fuel filter. And once I put the fuel filter on there, it didn't look that way anymore. It was smooth, and it, you know, accelerated normally, and the burn line was nice and level and all that. All right, so the evaluation is the initial spark kilovolt starts well. As the fuel is consumed, spark voltage raises with increased resistance. If that spark was dropping instead of rising, it would mean too much fuel. But what we got right here is a clogged #2 fuel injector. And that's how you track down a fuel problem with a scope, or one of the ways you can do it. Mac Vandenbrink, I had written that article, and I've talked about it on here, called Scans, Tools, Oscopes, and Toothpicks. I wrote for Motor Age magazine, where I had did a whole bunch of work trying to figure out a bunch of wonky stuff that was going on with this Jeep. Then I found out it was the cam sensor synchronization, and I said it with a scope, but I could have said it with a toothpick. And so I called it Scan Tools, Oscopes, and Toothpicks. And Mac Vandenbrink read that article, and he sent me a copy of one of his scope PowerPoint presentations and a toothpick in an envelope. Max, but rest his soul's already passed on, but he was really sharp when it came to a scope. He could look at a scope pattern and tell you if the lobe was rounded off the camshaft, you know, and explain exactly how he got there. But anyway. Other patterns, this is a bad plug wire. If you see one that looks like this is what a bad plug wire looks like. And I don't know how many times I've seen that. Of course, it can't. A bad spark plug can do this if it's if the ceramics cracked down inside the plug where you can't see it, you know. Waste spark waveform is what you get with a with coil pack. You know, where you got pairs of cylinders being fired by their own coils. That's an old thing that motorcycles did for a long time. But anyway. All right, so it's 2003 Z car. They had a 350Z manual transmission, 106,000 miles. He had just bought it from an individual. The guy didn't do any pre-purchase inspection. It was word of mouth. Oh yeah, have you ever had it? Oh yeah. Word of mouth service history. You know how that is. Oh, I've changed the oil every 3,000 miles. Blah 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 blah. The check engine light was on. It didn't have any power. It wouldn't rev past 2,500 RPM. It had a heavy misfire. It was really bad. We pulled and sorted the codes. Got a lot of garbage codes. You got to recognize the fact that when you just record all those codes, erase them, and start over. See what sets first, and that's ones you're going to go with. Then we moved on to the engine faults. P0011, P0021. See, both of the banks were not, you know, lined up like they should have been. Camshaft sensor circuit, bank 2. Now that was an interesting right there too. So all three of those codes are significant in what we're going to find here. And they looked it over. The timing cover had new silicone oozing around the gasket. When you see that new silicone oozing around the gasket, you know the cat's on the roof. Somebody's been there. There was brackets missing, wiring that had been quote unquote repaired, so on and so forth. And so the cam and crank scope. Well, it scoped both cam position sensors and the crank position sensor to verify the signals, as well as getting an idea what the engine timing was. Okay, so both banks were retarded based on the waveform, but the signal from the bank 1 cam position sensor was garbage. See, it had this faulty signal here that he captured, and see how this is a good one. And see this, look at this nonsense. It just go up here and stay up there. And that was no good, you know, on that cam sensor. One of the cam sensors looked okay. The other one was a mess. That was a bank 2 one. I had a Nissan Altima one time, and I got the scope patterns captured somewhere that was showing, you would swear looking at that scope pattern that the camshaft was out of time. I mean, you just swear it was. And it had a new cam sensor that was an OEM that had been put in there by a dealership somewhere up north of here. And so whenever I went to the trouble to break everything down and make sure it was in time, and sure enough it was in time, which is kind of tricky to do because those, you know, those colored links on those chains, they don't line up every time the thing comes around. You know what I mean? They just don't. That colored link walks all the way around, and then finally it comes back to where it's lined up again. That was kind of like the timing marks on some of those Eagle Talon balance shafts. You could put it on there where it was perfectly lined up, but if you're going to turn it through until it lines up again, you're going to be turning a lot of turns, and that's the way these colored link timing chains are. Anyway, so this guy said, well, I'm going to go ahead and put a cam position sensor on that bank. So he put the cam position sensor on that bank, but it turned out both banks were retarded after he got the signal like it was supposed to be. Both banks were retarded 16.77 degrees. And you can, I drew these lines here so you can get an idea. You notice this is the crank sensor. And you notice how this is a little bit over to the left. See, I drew that line so you're lined up with the with these cam sensor spike, or, you know, windows. And this right here is the bad one. That's the good one. This is retarded. You got, in other words, the crankshaft was running 16.77 degrees ahead of the camshafts. This is a known good waveform I use to compare these. But you can see the difference in the gap right there and there. That's that little bit of difference. If you don't have a known good waveform, you're not going to find something even with a scope unless something just jumps out and grabs you. Incidentally, on that Altum I was talking about earlier, it was in time, but the only thing that was causing that thing to be out of line was a bad cam sensor, and that's the only time I ever saw that. It was a beautiful digital signal, but it was showing the engine to be out of time. When I put a cam sensor in there after we found out it was in time, it lined up. This one here was out of time. He removed the timing cover, found somebody had put a new water pump on it, and when they put it all back together, see, you got this colored link here. It was a 1 in a million that these just happened to be lined up when he pulled it back off. You see, that link's perfectly lined up with that mark. That link's perfectly lined up with that mark. And this one here, this colored link, is out. You see that? And see, the engine turns this way, right? And so it should have been, if this link was down here, see, that's your 16 degrees right there. And so that's one of the ways that a scope helps. And the Pico scope has got some really handy math functions where you can get, you know, degrees of crankshaft rotation and all kinds of stuff that you can set it up, because they set it up. Pico scope does a lot of different things for a lot of different people worldwide, but it's got some really heavy duty automotive functions too. All right, here's question 1. What will this line do if you stretch the spark on this spark plug? This is the firing line. This is the burn line, or the spark line. And that's that up kick, and there's your squiggles I was talking about earlier. This is sort of a perfect example of what one looks like. Well, let's look and see what the answer to this question is. When it's not stretched, it looks like this. You notice this is longer and this is shorter. Now watch. You stretch it, this gets shorter, that gets longer. When it's not stretched, see that? This is longer and that's shorter when it's not stretched. When it is stretched, it goes up. So that's what that's going to look like right now. It's just stretching the spark. Sometimes when I had one that I knew the plugs were fouled on, you know, if it was one with a distributor, I would stretch the spark from the coil to the center post on the distributor cap. And that would increase the intensity of that spark, and it would overcome those spark plugs that were fouled, and it would start firing them. The engine would start up, and then I would let that thing run, jump in that spark about 3/4 of an inch, and so that good hot spark would burn all that stuff off those spark plugs, and then I would put it back down in there. When it ran smooth, I would know that, see, the spark plugs would be fouled for some other reason, you know, like somebody flooded it or whatever, or maybe they had driven it too much cold and the choke was, you know, closed enough times on enough drive cycles that it caused it to foul the plugs or whatever, you know. Question 2. What does this upkick in the spark line mean? All right, let's look and see what the answer to that question is. All right, when the fuel is used up, the resistance increases and the spark is extinguished, and this squiggle is what we'll talk about next, right there. All right, question 3. What do these squiggles mean? Now, I talked about that earlier. That's leftover energy. It's like snapping a rubber band. You know, this little, you know, if you don't see leftover energy here, then typically that means you've got a weak ignition coil that's running the engine, but if you have one like that when you snap the throttle, you know, if the coil is weak enough, it'll sputter and pop. As a matter of fact, on the ones with the distributor on them, when I was working at the Ford place, and I'm talking about the newer you know, the potted coils that they came out with, the E-core ignition coils, I would take a test light and I'd hook it to the ground side of the battery, and then I would touch it to the negative terminal on that on the ignition coil, and I'd see a nice steady flicker. Now, if I saw a flicker that was going pulse, 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 I'd know I had an open plug wire. But if I didn't see that, I was robbing just enough energy to weaken the coil spark just a little bit, and you would see this change. And then instead of being a squiggle, it would be just a dip, and then it would come up when that test light was connected. And then I'd snap the throttle. Now, if you snap the throttle with that low impedance test light connected, and it sputters and pops, I would say needs spark plugs. If it didn't sputter and pop, I'd say these plugs are good. I didn't even have to pull them out and look at them. Now, if I was chasing a misfire or something like that, I would. But you know, sometimes when I'd see one that was running bad, if I saw an aftermarket ignition module on it, I'd replace the ignition module. That would take care of it. If I saw one that had Bosch platinum spark plugs in it, I'd just jerk those things out and throw them in the trash and put some good spark plugs in it. Bosch spark plugs are okay if you're putting them in what they were made to go in. You know, Volkswagens always use Bosch spark plugs, you know. Well, this is the energy that's left over after all the fuel is used and the spark is extinguished. That's what I was talking about earlier. All right, question 4. What is this pattern? Now, this right here is an interesting pattern that you're going to see on most newer vehicles, you know, for about 25 years now. This is multi-strike, where the coil fires 2 or 3 times in succession when it's idling. Now, when you crack it off of idle, this goes away. Now, your hot rod guys with MSD ignition, it does this all the time, you know. But on the newer ones, it's going to idle better and it's going to start better whenever you got this multi-strike. But this stuff, if it bites you when it's idling, Donnie was working on this Escort one time, and Escorts had multi-strike ignition, you know, since the early 90s. And I was standing there watching him, and he says, I think I've got something going on over here with this plug. And he reached over there, and he was standing by the driver's side fender when he reached over there, and that thing reached out and got him, and he banged his knee against the fender, banged his head on the hood, and staggered back against his toolbox. And he looked at the fender, there was a dent in it. And he says, did I dent that fender with my knee? That was one of the funniest things I ever saw, you know. Now, I never did shock anybody on purpose, except for one time I charged up a condenser with an ignition coil voltage. You know how you charge up a condenser out of a distributor, pop, 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 you know, lay it on the block and let it, and then you throw it to somebody, when they catch it, you know, it bites them and all that kind of stuff. But that's not going to hurt anybody because it's only in that one hand. It doesn't make a blister or nothing. It's just a shocking experience, you know. All right, question 5. What is this pattern right here? Now, that pattern down there looks a little different. If you know what that pattern is, you've been a scope guy, you're going to know for sure. That is the fuel injector pulse. And watch it. Whenever you put more fuel in there, it gets wider, less fuel, more fuel, less fuel. And I have actually had looked at that whenever I was trying to figure out what was going on. The millisecond pulse is measured from here to here. This is when the injector is open. Now, when the injector is, when that field is released, that magnetism goes sweeping across that copper winding in that injector, you're going to get about a 40 or a 50 volt spike right here. This is perfectly normal. There's nothing wrong with that. Now, on these, the tall spike is the initial jump. See, this one here has actually got burn time, burn time, burn time. It's got 3 different burn times, 3 different firing spikes. If you happen to check scope you know, something like a Crown Victoria that's got cop coils on it, you're going to see this triple spike. Now, my Explorer just does 2 strikes. It doesn't do 3. And the Escorts used to do 3 or 4. I mean, there was I think 3. There was a bunch of them on those. I had a little Escort down there I used for a trainer car, and I would always show the students that. Question 6. What does this bad pattern tell you? This is a bad pattern. This is a good pattern. This is basically, this is on a 5-4 3-valve. And this is a pattern that I captured on one that we were working on. And so you might notice, look at this really careful. Here's your good pattern. I like to look and see where this is. Actually, this is supposed to be, if it's only got one cam sensor instead of two, then one of the cam sensors is supposed to be crossing the midline 8 points after this, but you don't have a way to adjust these cam sensors. But anyway, let's see what this is. Comparing the good to the bad collected during diagnosis, one camshaft was out of time. We had a cam phaser problem on this one here. Notice this one here is lined up. See that? That's the good pattern. And that one, it's lined up the same way. See that? But these two ought to pretty much mirror each other. This is a good pattern, but I don't really, it's good enough, but I don't really like it. This one here actually ought to be a little farther that way so that it's more perfectly lined up than that. But this makes the point. If you don't have a good pattern to compare your bad pattern to, and their IETN's got some good patterns you can pull, and there's a Facebook page that's about automotive scope patterns, where they got a lot of them uploaded from Picoscopes. The Picoscope software is free. You can download it to the computer. You can look at Pico waveforms. You can manipulate them and all. But you got to have a really expensive Picoscope, $1,500, whatever they're costing now. I had one at the college in order to do that, to gather the waveforms. But you can actually download the waveforms. I got a waveform library that I look in when I'm trying to do research and all. Question 7, what 3 inputs were used by the software to do this test? Now this was one that I captured using ACE misfire detective, which was, it had this neat little graphic it would do about what you had to do. This is a relative compression test. I have got a BT608 Autel tool that's it's made mostly for checking batteries and charging systems. It's really nice. It costs, if you get all the stuff that goes with it, it costs about $800 or something. And I need to demonstrate that one day for one of my videos. But it actually will do a relative compression test, and it will pull codes. It does all kinds of cool stuff because it's plugged into the, it's got a dongle that plugs into the DLC anyway. Whenever you're doing your testing of your charging system, it gives you alternator ripple. It gives you all kinds of stuff. But this particular was done with a Picoscope and ACE misfire detective, which was a super expensive piece of software, and I did not. I wasn't terribly impressed with most of what it would do because it was supposed to use a pulse sensor in the exhaust and a number 1 trigger pickup, and it was supposed to find a misfire based on the puffing in the exhaust based on when it happened. It wasn't accurate. You could tell it to check it several times and it would give you different cylinders, so I don't know that ACE Misfire Detective, unless they've improved it. At the time that I was using it, I think it cost $1,200 just for that software, and that's when you already owned a Picoscope, right? But it came with a pulse sensor. You can make a pulse sensor with some of those little acoustic pickups that you buy. You can buy 10 of them on Amazon for like $7.50, and if you put one of those in a closed chamber, like and it actually will give you a beautiful pulse. You got to actually put it in a closed chamber so it doesn't rattle around. It's got to be in foam so that the pressure can work on it. But if you put one of those in there, hook up, to the two sides of that little acoustic sensors, like when you put in a guitar, you can basically tap on this and you'll see it squiggling. But if you hook that thing up to a hose that's going into that chamber and stick it in your exhaust or put it in your intake or put it in your fuel rail, you can see pulses and everything on your scope really good. Anyway, let's move on with this one. Voltage at the battery, current to the starter, and number 1 plug sync. See, we found 2 plugs, two that didn't have good compression. They were, and what would happen was whenever it would hit that cylinder, once it knew where number 1 plug was, it could tell you which cylinders. It would pick up speed whenever it was spinning. See, that's what it sounds like, and I know people get tickled when they listen to me making noises and all. All right, question 8. What is a waste spark system? All right, what about that question there? All right, this is each coil fires companion cylinder plugs, and what you got to remember is one of these fires out the other one fires in, because this is a closed loop right here. That's a closed loop. And some people, you know, we were taught early on when these systems first came out that if you disconnected this spark plug wire from this one, and that one would quit firing. But that's a bunch of hooey. That ain't right. Because you know, you think, well, I broke the cycle, but that spark is going to find somewhere to go. And if you disconnect that one, this one here is still going to fire. Sometimes you'll have a situation on this particular type here. This is like for a Chrysler Neon. If you're checking spark on this one, you just need to disconnect both of these wires, and you need to check spark from here to here, or you're going to see what looks like a weak spark. And that's not a good plan if you're trying to troubleshoot something. So if you want to make sure you got good strong spark, check from here to here while you're spinning it over. Don't just unplug one wire and check the spark from one post, because that's not a good test. I found that out the hard way. But look at this. This was on my Explorer right here. You notice my Explorer just got 2 of these. This is on my MixSig scope that I've got out there. Alright, you notice plug 1 and plug 5 are companions, right? Look at the difference in the wear pattern on plug 1 and on plug 5. See, it's got to do with which way the spark is jumping. And see, I even actually superimposed the scope pattern, the picture of the plug over the scope pattern, and that was another video I did, pretty good while back, you might look up. But anyway, keep that in mind. On the Crown Victorias, the ones that had the spark plug wires and the 2 coil packs, one on each side, they had those specifically wired so that all of the plugs on one bank were firing in one direction, like from the center electrode out. So it was going pop, 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 starting here, popping out. And on the other side, it was firing from the ground electrode in, pop, pop, pop. Typically, the one it's popping from is the one that loses material, from what I understand. Of course, I haven't been able to watch this close enough to tell, but whenever it's difficult to tell which way it's going, but it's going to wear out, from what I'm able to tell, the one that it's jumping from, not more than it is the one it's jumping to. Or I could have that backwards, so don't quote me on that. Some of you guys may know better than me about that. But anyway, on the Crown Victoria, if you lay those plugs out, the left bank plugs and the right bank plugs, all of the left bank plugs will have the same kind of wear pattern, and it'll be different from the wear pattern on the right bank plugs. And that's on the ones that's got the 2 coil packs and it's got plug wires, right? So that's why they've got those things wired up like they do. And I thought that was very interesting that they were so critically trying to make sure they got that right. Question 9, what's the difference between closed loop fuel control and open loop fuel control? Alright, I want to quantify what's going on here. Open loop, PCM's not using O2 input, which would be wide open throttle, cold engine, closed loop. If it's got some kind of problem, it'll open loop, like if it knows it can't trust the oxygen sensor. PCM is using the input to determine fuel trim if it's in closed loop. I went to school in 1981 in Houston under Ellen Smith, who was a GM instructor, and she was really sharp. That's the first school I actually ever went to after having worked on vehicles for 6 years already, getting paid to do it. Anyway, I went down there and she explained open loop and closed loop so that I instantly understood what she was talking about. 6 years later, when I went to work at the Ford place, the shop foreman at the Ford place where I went to work, neither one of them really understood open loop or closed loop. They didn't get it. They just didn't understand it. It hadn't been explained to them. And they've been, dealing with this stuff for a while. But this illustration down here is a different feedback loop, and there's feedback loops all over the place in these engine control systems. It's going to be looking kind of like a thermostat in your house. It turns on the air, brings the temperature to what the thermostat set on, turns it off, turns it on. That's a thermostat. And this right here is basically a feedback loop. It's only one of the ones. You got target RPM is set in this PCM. Idle air control is told to do something about it, or the throttle body if it doesn't. If it's got electronic throttle body, right? Okay, and so the engine responds to that or doesn't. Engine speed input. The mass airflow is basically, it's a rationality check. So if it increases this, it expects that to go up. See, if it's got a target RPM it's trying to reach, if it says I want 1100 RPM, but all it can get is 600 or 700 or 800, then there's issues there that it needs to set a code, right? If the mass airflow, if you take your throttle position sensor and your mass airflow and you put them on your scope together, then, and I'm talking about, I always did this with, you could do it with any of them I expect, but the redundant TP sensors on these electronic throttle bodies is kind of wonky. But if you take like a regular old TP sensor and you're scoping it and you're scoping the mass airflow, when you open that throttle, they ought to track together. If they don't, you know, you got some kind of an issue. Anyway, that's this was kind of a little funny story I'm gonna tell you before I go. This guy named Mark that was working over close to me, not Mark, there's two Marks over, but he says, I can't get this Ranger to idle right. And I said, well, you need to take this hose off over here, clean that out, wash out the throttle body, disconnect the idle air control, and with it idling with the air inlet tube hooked up, you need to adjust the screw right there until it's idling about 550 RPM, then put it all back together. I gave him all those instructions one after another, and he did what I told him to. And he came back over there and he goes, man, that worked really good. You must have seen this before. And I said, nope, never have. I just knew what to do. And he grabbed me by the throat. Ah! That was really funny. What system is this? Everybody that knows anything about newer vehicles is going to know that this is the evap system. Evap canister, vent solenoid, purge solenoid, fuel tank pressure sensor. And basically, this is just one of the many different types of evap systems. There's all kinds of different types. This was the standard kind that domestic cars used. Chrysler went away and they had a funky, can't remember what that darn thing was called. It was a big old thing underneath there that did it a different way. They also have natural vacuum, natural leak detection, and what they would do is they shut it off. Everything's closed up at night. They expect the pressure to change because of the temperature, and they got a switch that opens and closes natural you know, natural NVL, I think they call it. But this is the one right here that is easiest to explain. You got manifold vacuum that's purging the solenoid, right? And so this is purging, right? And it's basically, this is not hooked up exactly like this, but the vapor comes in here, stored in the evap canister, and whenever, and this is open all the time, unless there's a test going on, then purge solenoid draws that out and runs it through the manifold, and there's the cells that it uses in there to determine what to do with the fuel trim will calculate when it's purging and when it's not, so it knows to expect a little more fuel when it's purging. Now the Jeep and Chrysler called the cells where it wasn't purging, they call those purge-free cells. And you know, think of each cell as like a card that's dealt for each particular given situation. Fresh air comes in here. Well, when it closes this, it's got all of this locked down, and it puts a little bit of water vacuum in there. I mean, I say water vacuum because it's not mercury vacuum, it's just a tiny little bit of vacuum. Watching this sensor, it locks it. It'll only do it typically if it's got more between 85% and 15% fuel in the tank. If it's too full or not full enough, it'll go a long time without running this monitor. So keep that in mind if you're trying to get an evaporative monitor to run whenever you're test driving one. Got to be between 15 and 85%. But it locks that, it closes the vent. So that's got the vacuum it's putting on the tank, the canister, and everything. And then when it closes this, it's holding that, and the PCM is watching it. It doesn't want to see that decay. It doesn't want to see it bleed off. Okay, so if it bleeds off, then it knows that there's a leak. And if it's a 20,000th of an inch leak, it will pick up on that. Now then, it releases the vent, and it watches how fast the pressure returns to normal. If the pressure returns to normal too slow, then it sets a code for that too. Of course, if you leave the gas cap off, you know, sometimes it'll turn on a gas cap light on your dash on some cars, or it'll set up PO 455. One time the service manager came out there at 5 till 12 to my service bay, and he goes, I know you're getting ready to go to lunch, but I'll buy your lunch if you'll come out here and look at this Lincoln and see what this check engine light's about before you go to lunch. So on there, pulled the code, PO 455, went back there, the gas cap was loose, tightened the gas cap, cleared the code, and I said, okay, we're good to go. And so, because I'd seen that zillions of times. And so, it was like 2 minutes till 12 by the time I got it fixed. And the service manager says, well, since you didn't have to work into your lunch hour, I'm not going to buy your lunch. So he didn't make good on what he said he was going to do, even though I fulfilled my part of the bargain. All right, have a great week and take care, and I hope you guys enjoyed this video, and I hope you stayed till the end. If you didn't, you missed out on the pop test. And I'll talk to you guys next week.